I welcome to you all again to this another lecture which is the based on gear drive. I am Dr. Ashish Vikhar and today we will learn details regarding gear drive. In previous lectures we have seen the information about belt drive and chain drive. All these equipments or devices are used for power transmission, and one of the another option for power transmission is available, and that is called as a gear drive. In front of you you will see the different types of gears. In the picture on the left hand side you will see that there is a spur gear. So this is a spur gear. After that, this is another gear. This is a picture of another gear which is called as a rack and pinion gear. Here you will see that this is a bevel gear. After that, this is a worm and worm wheel. After that, you will see here internal helical gear, and these are the helical gears. So this way there are various types of gears available, and all these gears are used in power transmission. This is very important picture. You will see that the applications of various types of gears in one place. As you can see here, this small boy, a small child, is on the cradle, baby swing, and that is attached to the first type of gear here. This is the called as a rack and pinion gear, rack and pinion gear, and the power from that is going to be transmitted to another mechanism which is called as a ratchet Powell mechanism. Further, you will see that there is a application of screw gear. After that, the power is given to the worm and worm wheel. This is a worm and worm wheel. Through the internal gears, that power is given to the gear coupling through gear coupling to involute spline shafts and bushings, and from that place it is given to the meter type of gear. From the meter gear you will see again the power is given to the involute spline shaft and bushings, and from that you will see that there is application of helical gear. Then there is a power is given to the spur gear. Then you will see that spiral bevel gears are there, straight bevel gears are there, and finally at the end you will see the power is reached. So this is very beautiful figure which explains the applications of different kinds of gears. So we have to understand how the gears rotates, how is the structure, how is the appearance of such type of gears, that we are going to learn in this unit. But let us see what are the contents of this chapter number 4 of theory of machine, which is based on the gear drive. First we will see introduction to gear drives. After that we will learn about classification of the gears. Next we will learn what is law of gearing. This is a very important law in case of gear drives. After that we will learn gear terminology. Then what are the types of gear trains, which are the different types of gear trains. Then we will learn about train value and velocity ratio for simple, compound, reverted and epicyclic gear trains. So gear trains are there. First is simple gear train, second one is compound gear train, then third is reverted gear train, and last one epicyclic gear trains. Then how to determine the velocity ratio regarding all these types of gear trains, using what spur and helical type of gears. So that we are going to learn in this chapter number 4. After that we will learn about what are the merits, demerits and selection of gear drives for the given applications. So these are the total contents that we are going to learn in chapter number 4, but particularly in this lecture we will only learn about introduction to the gear drives. So what is meant by gear drives? So gear drive is used when center to center distance between the driver and the driven shaft is very small. So when center to center distance between the driver and driven shaft is very small, then we can implement gear drives. Suppose these are the two shafts. This is a shaft number 1 and this is a shaft number 2. Between that, if the distance, this horizontal distance x is very small, then in that particular category we can use gear drives. So gears are defined as toothed wheels which can transmit power and motion or speed from one shaft to another shaft by means of successive engagement of teeths. So teeths are used in case of gear drives. So in this way we can define the gear drives. Toothed wheels, it is a toothed wheel which can transmit power and motion from one shaft to another shaft by means of successive engagement of teeth. So here after that you will see that picture of a gear drive. Here you will see the spur type of gear. This is a picture of spur type of gear, in which you will see that the first shaft is at the upper side and second shaft is at the lower side. So at the lower side you will see that there is a application of gear which is having different teeth like this. These teeth are meshed with the pinion type of gear which is smaller in size. So pinion teeth are engaged with the gear teeth. So these gear teeth are engaged with the pinion teeth, and this shows one of the option of one of the type of gear which is called as a spur gear. This is nothing but a side view. So here you will see the pinion shaft, gear shaft, and on this on the gear shaft gear is mounted. This gear is mounted on the pinion shaft, the pinion is mounted. So this is the sketch of gear drive. In this particular figure you will see that you will note that both the gears which are engaged always in opposite direction. You will see that this is very important. Both gears which are engaged always rotate in opposite direction. If this gear particularly this gear is rotating in anti-clockwise direction, then the motion of this pinion is in the clockwise direction. It is clearly showing that the motion of pinion is in clockwise direction while the gear is moving in the anti-clockwise direction. So gear drives consist of two wheels. The smaller wheel is called pinion. So the smaller wheel is called as a pinion. So this is a pinion, this is a pinion, and larger wheel is called as a gear. So this is called as a gear. So this is a particular gear. So in gear drive slip is absent, which is nothing but very important parameter regarding the gear drive. Slip is totally absent. As you can see, in case of belt drive there is a slip, but in case of gear drives there is a slip which is absent. Therefore it gives exact and uniform velocity ratio. So exact velocity ratio is achieved in case of gear drives. So therefore this is very important advantageous point of view of the gear drive. So due to this ability of maximum power transmission and exact velocity ratio, gear drive is called as a perfectly positive drive. So it is called as, why it is called perfect positive drive? Because it transmits maximum power and it gives exact velocity ratio, and that's why there is no slip, and that's why it is called as a positive drive. So because of this gears are various advantages. So what are these advantages? So gear provides exact velocity ratio. After that it gives very high efficiency. The layout of the gear drive is very compact. It is having the ability of transmitting larger power, maximum power can be transmitted, and it gives very reliable service. So these are one of few advantages of the gear drives. It is having certain disadvantages also. What are the disadvantages? The first disadvantage is manufacturing of gear requires special tools and equipment. So if you want to manufacture gears, then we need special tools and equipment, and this leads to high production cost. So this is a very first disadvantage. After that, complicated manufacturing process is there to manufacture the gear drive. Gear drive requires precise alignment of the shaft. There should be the precise alignment of the shaft. After that, costly lubrication system is required for smooth operation and longer life of the gear teeth. So lubrication is needed, and which is again very costly. And why it is needed? For the smooth operation and longer life of the gear teeth. Any error induced in the gear during the process of the teeth cutting leads to noisy operation with severe vibrations. See, so severe vibrations are produced, noisy operation is there when any gear during the process is going to cut. So if there is an error, then it is giving very noisy operation and severe vibrations. What are the applications of gear drive? Let us see one by one. These are used, gear drives are used in gearbox of the vehicle, in machine tools, in case of dial indicator, gear mechanism of wrist watches, differential mechanism of automobile, and cement mixing units. So these are few examples where we can use the application, or where we can use gear drives. Now let us compare between the gear drive and the belt drive. In the last lecture we have seen the details regarding the belt drive. Now on the basis of some basic factors we can compare between gear drive and belt drive. So first is a space, first is nothing but space. So gear drive requires less space compared to the belt drive, while belt drive require more space compared to the gear drive. Second parameter is low friction loss or friction loss. So there is a low friction loss in gear drive as compared to the belt drive. Therefore higher efficiency, higher transmission efficiency, power transmission efficiency is high, but in case of belt drive it is having high friction loss. Therefore belt drives are having lower transmission and lower efficiency. Gear drive requires less maintenance, but maintenance cost is relatively cumbersome, while belt drive requires high inspection and maintenance cost, and it is cheaper and convenient. After that, in case of gear drive much greater life expectancy is there, but in case of belt drive low life expectancy is there. After that, complicated equipment design and tolerances are very much important in case of gear drive, but in case of belt drive easy flexible equipment design, easy flexible and equipment design is there, as tolerances are not important. In case of gear drive no isolation from shock and vibration, while in case of belt drive isolation from shock and vibration between driver and driven system exist. After that, gear drive requires regular lubrication, belt drive requires relatively less or no lubrication. That in this way we will see that another disadvantage is nothing but gear drive is noisy in operation and belt drive is very quiet in operation. In this way we can classify, we can differentiate between gear drive and the belt drive. After that, seeing the difference between gear drive and the belt drive, let us see what is the difference between gear drive and chain drive. In the last few lecture we have seen the chain drive, details regarding the chain drive. So in case of gear drive power and motion are transmitted by means of successive engagement and disengaging of teeth and mating gears. So teeth of mating gears are used in case of gear drive, but in case of chain drive power and motion are transferred by means of successive engagement and disengagement of chain. There is a use of chain with a sprocket. So chain and sprockets are used in case of chain drive, but in case of gear drives teeth, mating teeth gears are used, teeth of mating gears are used. In case of gear drive no additional element is required in gear drive, only two gears are sufficient for power transmission, only two gears are sufficient for power transmission. But in case of chain drive, apart from two sprockets a chain is indispensably necessary. In case of gear drive it is not one flexible drive, thus it cannot protect the driver unit from vibrations induced in the driven unit. But in case of chain drive presence of flexible element like chain, flexible element of chain is there, that makes it one flexible drive. It can easily isolate vibrations and thus can protect the driver. Gear drive is suitable for small center distance between the driver and the driven shaft, but chain drive can be employed for short as well as medium center distances. Gear drive requires precise center distance and alignment for satisfactory performance, while center distance and alignment are not so critical for the chain drive. Gear drive requires full lubrication, while chain drive requires periodic lubrication. So gear drive offers 1:1 to 1:40 velocity reduction or velocity ratio. In case of chain drive it can use for a velocity reduction up to 1:10. In this way we can differentiate between the gear drive and the chain drive. Thank you very much.